On number 26 and 28, we are given instructions that say the graph is that of a function y equals f of x that can be obtained by transforming the graph of y equals the square root of x. Write a formula for the function. So the way to approach these is to think about what the parent graph would look like, which would be like that. And I'm kind of being a little sloppy there because, in essence, the only change is that one. And theirs is looking a little taller than mine. But on these, if they don't tell you there's a stretch, assume there's not one. So we do see that we have a horizontal reflection. And we also have a horizontal slide. That's a ditto mark for horizontal. 3 right. Okay. Now also notice this negative 10 by negative 10, 10 by negative 5, 5. Remember, that's just telling you that this is negative 10 out here and this is positive 10. And this is 5 up here and negative 5, and I can't squeeze it in because it's already written all over. That's just giving you your window size so you can look at the scale. But remember, to get a horizontal reflection, we have to have a negative coefficient on x. And to get a slide to the right 3, we would have to have a slide of 3 to the, we would have to have a minus 3 to get it to slide 3 to the right. Sorry, I'm trying to look at 3 things at once here. So we're going to write this equation 2 ways so that you can see how all that works, kind of in reverse order of the one we'll be doing in just a couple of minutes on the next example or two. So we will start by saying, okay, well, I got a negative, but you want parentheses like this, because the negative has to apply to whatever else is in there. And then right 3 would be minus 3. But then we don't want to leave it that way because that almost looks like you can't do it because it's a negative in there, and that kind of tricks your brain. But if you distributed that negative onto the x and the minus 3, you'd end up with 3 minus x, which would be a better, cleaner way to write this function. And then when we get to number 28, we have a little easier problem because of the fact that to me, honestly, the horizontal reflection is harder to think about. But here, if they don't tell you have a reflection, you don't have a vertical reflection, but here, stretch, but here you have a vertical stretch by 2, but that's pretty simple because remember, if we have a vertical stretch by 2, it's like code for telling you A is 2. So we already know that our equation is going to be 2 times the square root of something. Well, if you look at the coordinates of this point right here, it looks like we go 1, 2, 3, 4, 5 to the left. So our vertex has to be negative 5. And then we go down 1, 2, 3. So our vertex is at negative 5, 3. So to go to the left 5, I would have to have a plus 5 inside my square root. And then, that was a negative 3, and I didn't make it negative. And then down 3 would be minus 3 on the outside. So our equation for number 28 should be y equals 2 times the square root of x plus 5 minus 3. And then 30 and 32, we are to write the equation of the reflection of f across the x-axis and then the y-axis. So we'll start with A, which is the x-axis. And remember, to obtain an upside-down version of a graph, we simply make A negative. Well, in this notation, we will do the exact same thing, but you have to know that when the function is given as this one is, then our new equation, and I don't know what I just did, hang on. Our new equation, we don't want to call it f because we've already got an f, so let's call this g of x. Then g of x would be a negative that was distributive to the entire function. So write this step on all your examples, otherwise you'll confuse yourself and you'll have to remember how you turned whatever was there into what you write on your paper if you don't write that step. So the final answer should be negative square root of 2, x plus 3, and then plus 4. And that's that one. And then for B, since I wrote so big on A, I'll write smaller down here. Alright, and then for B, which is the y-axis, this is the one that's a little harder, which is why they have it second. It's harder, but it's easier, because really all you have to do is to plug in negative x to get a reflection. And then when you do that, you get 2 on the square root of negative x plus 3, and then minus 4. And the reality is that you don't see square roots written that way because you don't want to lead with your negative. So, and because remember, this is different from the horizontal reflection. This is simply replacing x with negative x. So this gives us, and if you find that confusing, you should probably graph both possibilities to see what I'm saying. Then the only other thing you should do here is rewrite that so that it's 3 minus x, because it's just good etiquette to never lead with a negative under a radical, because it tells your brain something is wrong when it's really not wrong. Now let's look at 32, same set of directions, but now we're going to look at this new absolute value function. And A is across the x-axis. That's the easy one. You just turn it upside down by multiplying by negative 1. Oops, don't call it F, call it G. And we didn't call the last one anything, so let's call that h of x. And then, oops, put it in the wrong place, my bad. Try that again. Let's go all the way down to the bottom. Let's call that one h of x, just to have different names for them since they're different functions. And then back on track, we have g of x. So we want this to be an upside down version of f of x, and this one is actually easier because there's only one term. So you just make that negative 3 x plus 5. And that's that. And you're done with that equation, much easier than the last. And then B, we're going across the y-axis. So we're going to, in order to make that happen, we're just going to say f of negative x equals, and so that would be 3 absolute value of negative x plus 5. And then, again, absolute values are kind of the same way. Lead with your positive term as long as you have one. So now we're going to call f of negative x h of x, just like we did on the last one. So we have 3 times the absolute value of 5 minus x. And that takes care of, what number was that? 32. And we're done with that problem and this video. So that's your equation and the video.